So there is a readiness probe for pods. We haven't looked into that, which would be something that I'd like to add in the advanced Kubernetes course. So you can basically define a command that tells Kubernetes when the pod is ready. So let's say, for example, you're booting up a very large Java app. So if you ever booted a JVM, like invoking something that requires a JVM, you can see that there's a multiple second delay. So it's not enough that a process is started because the application may not be ready. So you can have a readiness probe that tells Kubernetes when the pod is ready. So that's why startup time of the container and even a process is not necessarily equal to the container being ready. So there are two different other probes, readiness probes and liveness probes, that doing certain changes are helpful to ensure minimizing the service impact. And that makes that question a bit more complicated. So once new pods are ready, old replica set can be scaled down further. Yeah, sure. For each pod that actually is ready, you can scale down another pod, followed by scaling up the replica set, ensuring that the total number of pods available at all times during the update is at least 70%. So yes, it would round down. So if you say 33% and you have 10 pods, your in-flight limit would be 2. Now, interesting, what is max search? Max search is an optional field that specifies the maximum number of pods that can be created over the desired number of pods. Ah, interesting. The value can be an absolute number, For example, when the value is set to 30, the new replica set. So this is interesting. So think about, we have 33% and 10 pods. If you don't want more than 2 pods to be offline, but you'd still like to create 3 pods simultaneously, then you could allow temporarily having 11 pods, because there would be 3 new, others being teared down. So the temporary number of pods could be higher than the number of replicas. Is that what it's basically saying? Yeah. So when this value is set to 30%, the new replica set can be scaled up immediately when the rolling update starts, such that the total number of old and new pods does not exceed 100% of the desired pods. Yeah. So you can allow a temporary increase in the number of pods for minimizing the impact on the service, which could be interesting if, for example, the 10 pods are already, let's say, more or less what you also need to serve your load, as taking down pods will also increase the response time of your application, because load will be distributed across less replicas. So ensuring that there's a certain number of replicas is important. And you could also do a rolling upgrade by not tearing down replicas, but by adding them. So I guess that's the point here, having a max search versus an max unavailable. So in this case, where we want to delay the deployment, we could spec strategy. So you can also see there's a train wreck. And this actually goes back to the structure here. So it would be a spec strategy is second level. So that would be strategy. And I'm using spaces here. Rolling update. Max unavailable 1. Well, let's give it a try. Blue, we're back to blue. I want my describe ready. Yes. All right. As you can see here, we now have 2 replica sets. That is exactly what we expected, and that you can see how these are balanced. One is scaled down, the others are scaled up. Once it's done, the old replica set is destroyed. All right, so to wrap it up, we have 2 strategies: recreate and rolling update. In a rolling upgrade, we can control how many of the application instances of the pods will be removed. We can therefore ensure how many of the replicas will remain, and we can also allow increasing the amount of coexisting pods temporarily beyond the number of replicas we have specified. So this will give us a very good control over what's happening. For a recreate strategy, we don't need that, because we basically shut down an entire replica set, which takes a while, because shutting down a pod may take a while, and shutting down a large number of pods takes a little longer. And only after all the pods are shut down, the new replica set is created, and the new replica set will be scaled up, which also takes some time. So as we have seen, even with a low number of replicas, the service impact of the recreate strategy was rather significant. All right. Controlling a rollout. Well, in case you have a trouble with your rollout, there's the ability to pause and resume a rollout. You should be aware of that. I think in our example here, it doesn't really, we don't need this. So let's look into the history. So you can also see that there's Kubernetes is keeping track of the revisions, and if you then find you would like to look into a particular revision, you can also do that. Well, that revision isn't available anymore, but we can, for example, look into the deployment of a particular revision like this. So if you then want to see how revision 5 looks like, so you can compare the two. You can also undo a deployment. So the last revision, I think we moved to blue. So we describe the deployment. I'm not sure whether this undo of the rollout works, because the rollout was completed. So the old replica set has been destroyed, which would not necessarily be the case if we undo a rollout and we have a problem during the rollout.